All right, so I thought it might be helpful to see a video of solving the problems you had today to work in class. So this problem was presented to us with different things that we don't know compared to the example I did in class. But what I want to stress is a lot of the ways that we start this problem is going to be just the same as what I did in class. It's just how we move forward will look slightly different. So I mentioned that I think it's a good idea to just write our initial expressions that we're going to be working with so that we have them sort of at our disposal to then modify for the particular question that we're being asked. So I'm going to write just the general expressions for x and y. I'll do also vx and vy. And now we can move forward and we want to make them more applicable to our particular problem. Now, the thing that really, I think, threw people in this particular problem was that we were not given the initial speed of the ball, but we were given the angle. And so we don't want to get too hung up on the fact that we don't know what V naught is. That can be an unknown. That means that Vx naught can be written as V naught times the cosine of 45, and Vy naught can be written as V naught times the sine of 45. I did see people put in values for this, but the values that they put in were not speed values. The units didn't work. And we want to just resist the temptation to put a number in because we're uncomfortable with not having a number. Remember, in the end, we actually are being asked to find out what is V naught. So it makes sense that that's an unknown. We can also make the decision to let our initial position values be 0, and that's going to simplify everything. So I'm going to use these pieces of information that I have, and now I'm going to rewrite x and y as they apply for this particular problem. So I'm left with these expressions for x and y now that I've substituted in the values for the x, the initial x velocity and the initial y velocity, and our initial x and y positions. Now, what do I know? Because I want to solve for V naught, and I have to use the information that I know. I do know that when x is equal to 45.7, y is equal to 3. These things are true at the same time. So I'm going to put in these values for x and y. These are two simultaneous equations. Maybe they're not as obvious to you as maybe equations with x and y are, but the things we don't know is we don't know V naught and we don't know t. So let's just think of our algebra skills. What do we do when we have two simultaneous equations and we want to solve for one of the variables? We'll use this expression to solve for t. And we're going to use that expression for t and substitute it into the y equation. So what will I get? I'll get 3 equals V naught sine of 45, And now instead of t, I'm going to put 45.7 over v naught cosine 45 minus 1/2 times 9.81, and then 45.7 over v naught cosine 45, and all that is squared because that's the value for t. Now some things are going to happen here to simplify this. The v naughts cancel out in the first term, and it turns out the sine and cosine of 45 degrees are actually the same values, so I'm going to just cross those out as well. So what do I get here? Now I get 3 equals 45.7 minus 4.905, that's just half of the 9.8. And then I have 45.7 over v naught cosine of 45, and all that squared. Now this looks ugly, but when I look at it objectively, everything is a number here except for v naught. V naught is what I want to find. If I can get it all by itself, I'm going to be able to solve for my variable. So I'm going to take this over here. I'll get 42.7, and then I'll square the 45.7, multiply it by the 4.9. I'm going to get 20467 over v naught squared. I also squared cosine of 45 and employed that into the top. And I can rearrange this, and v naught squared can be written as 20467 over 42.7. Take the square root of both sides, and I get v naught is 21.9 meters per second. I know it's a lot of algebra, but this is algebra that you know how to do. And I just don't want you to be scared of moving forward because it looks like it might be a little bit difficult. Because I know that you can. You have the skills. You can do it. It's just a matter of kind of moving forward. Now here's a different type of problem where we have someone on the roof. It's 15 meters tall. He's going to throw something with a speed of 30 meters per second, and the angle is 33 degrees. And then we're asked to find a lot of stuff. And we'll worry about that in a minute. Let's look at Vx naught, which is going to be 30 times the cosine of 33. That's going to be 25.1. Vy naught is 30 times the sine of 33. That's going to be 16.3. I'm going to say x naught, I'm going to let be 0, but I'm going to let y naught be 15 because he's on the top of a 15-meter building. All right, this is just half a g, in case you were wondering what the 4.905 is. So here's some expressions. They're just very general. I'm going to substitute in things that I know to make these equations for this particular problem. All right, so these are the expressions I can work with to solve this problem. So the first question asks, what's the maximum height above the roof that the rock reaches? Well, I know that it reaches its maximum height when Vy equals 0. So I'm going to use that to find the time. So setting Vy equal to 0, I find that it makes its maximum height when t is 1.66. So I'm going to use that as in my y equation to figure out what the final y is. I end up with a y value of 28.58 meters. So that is actually the height measured from the ground. The question actually asks for the height above the roof, so that delta y would be the 28.58 minus 15. So that actually, it goes 13.58 meters above the roof. So the idea is that it goes up this high, this is 13.58, and then this was the 15. Those two added together give me my 28. All right. The next two questions are going to require me to figure out how long it's in the air, because I want to find the speed of the rock just before it hits the ground and the horizontal distance it goes. Both of those require to know the amount of time that it's actually in the air. So when it hits the ground, y will be 0, my y expression, just to remind you. And I'll set that equal to 0. And I'll find the time. I'm going to use the quadratic formula. If I do that, I get 4.07 seconds or minus 0.75. That doesn't make any sense. That's the amount of time it's in the air. So this is use quadratic. To find the horizontal distance it goes, I'll put that time in to my x equation. And I'll find that it goes 102.2 meters. To find the speed when it hits the ground, I want to find Vy. I'll find Vy is minus 23.6 meters per second. Vx is just its initial value, which is 25.1. The speed will be the square root of x squared, the velocity in the x plus the velocity in the y, both of those squared. Take the square root, and I'll get 34.47 meters per second. And so that will be that answer. So maybe you want to look at this problem first and then go back to the football one, because the football one was a little bit more challenging than this one.